Now that we have the calorimeter calibrated, we can actually look at heat transfers and enthalpy changes associated with chemical reactions occurring within. So I have inside the calorimeter now 50 milliliters of a 1.0 mole per liter solution of sodium hydroxide, and in this graduated cylinder I have 50 milliliters of hydrochloric acid. So what we're going to do is mix these two and use the temperature change upon mixing to determine the enthalpy change of the reaction and the molar enthalpy change. So as before, we need to note the initial temperature of the liquid, and I'm going to assume that both liquids are at the same temperature because they're both at room temperature. So using this thermometer reading, which looks to me to be again about 21.2 degrees Celsius, we can use that as our initial temperature. And as before, we're going to mix these and look for the maximum temperature achieved by the reaction solution. So I will quickly pour in the acid solution and replace the lid and swirl things around a little bit. Acid-base reactions are fairly rapid, so we should reach the equilibrium temperature in not too long a time. And again, as I mentioned previously, you should be recording temperatures every 10 to 30 seconds or so to make sure that you actually observe the maximum temperature here. So the reaction mixture appears to be topping out at about 28.0 degrees Celsius, so we use that as our equilibrium temperature, and the difference between the initial and the final or equilibrium temperature will give us a hint to the enthalpy change associated with this reaction. Do note, however, that you'll have to use the calorimeter constant because some of the heat released or absorbed by the reacting components either goes to or comes from the calorimeter walls.